Assalamualaikum and salam sejahtera. Okay. We meet again in on the course TMP3413, okay, Software Engineering Lab, okay, with me, Madam Nufawza. Okay, for the topic of today is Lecture 9, Integrations and System Testing. So this chapter covers both the testing and as well as documentation. So the chapter starts with the testing principles, test strategies, and test planning. Then we will review test measurement and as well as the tracking. Okay. Aside from that, okay, defect prone module also will be covered, and the implications of defect prone analysis on the testing as well. Okay, and we'll discuss the thing to consider when we produce the user documentation. Okay, finally, okay, we'll cover on the test scripts. Okay, test cycle 1 and test end cycle scripts. Okay, we review the TSP test process. Okay. Lastly, okay, these additional things that I add in this topic, which is the requirement traceability metric RTM. Okay. Testing performed to detect defects in the interfaces and interaction between the integrated component or system. In other words, software testing is also in investigations conducted to provide the stakeholder with information about the quality of the software product or even the service under the test. This software testing can also provide an objective as well as independent view of the software to allow the business to appropriately and understand the risks of the software implementation. And the test technique includes the process of executing a program or application in intent of finding software bugs, error or defects, and verifying that the software product is fit to be used. So for software testing, okay, in testing principle, okay, in TSP, the purpose of testing is to assess, okay, the product and not to fix it. Okay. Although you should certainly fix any defects you find in testing, you should have found and fixed almost all the defects before. Okay, you see, before the testing phase. Okay, you should have found and fixed almost all the defect before the testing phase. So when poor quality products are put into test, testing time is greatly extended, and you probably won't find most of the remaining defects. The quality of a product is determined when it is developed. So there's now refutable evidence that competent engineers who use standard software development method consistently produce poor quality program. Then when they put this program into test, testing takes a very long time and does not find all the problem. When you put a poor quality product time test, you generally get a poor quality product out of test. So with this TSP, the objective is to put quality program into test. Then in testing, you verify that products are of high quality. The principal TSP testing activity, as mentioned follow. We have first, using the developed and unit tested parts, build the system. And second, of testing activities, in TSP, integration tests, the system to verify integration test the system to verify that it is properly built, that all the parts are present, and that they functions together. Okay, the third testing activities in TSP is system tests. Okay, system steps the product to validate that it does what the system requirement call for. Okay, while doing this, we should also do the following. Okay, two following, which is identify poor quality modules or the component and identify poor quality components. Okay, and return them to the quality process manager. Okay, after you have done the cleanups. Okay, for the modules and component, and as well as you have done the rework and replacement. Okay, the overall testing step are build, integrated tests, and system tests. Okay, the build step assemble the various system parts into a complete system ready for testing. Okay, so this is called a system build. Okay, you heard of system build before. Okay, so integration testing then ensure that all the proper parts have been included in the system and that their interfaces are compatible and work together. Okay, and finally, system testing validates the system function, and as well as the performance against the requirement. Okay, in a subsequent development cycle, regression tests are also needed to ensure that the development work for the cycle has not unintentionally changed the functionality or performance produced prior to the cycle. Although all of these functions generally have been tested before, if you don't rerun the early test in what is called a regression bucket, you often do not know whether later change cause regression program. So read more on the regression testing and regression bucket. So the purpose of build uh, process is to ensure that all needed parts are present. Okay? Uh, to assemble a working system and to provide the system to integration and as well as system tests. So the integration strategy defines the approach to integration testing. Basically, integration testing should check all of the components are present and that all their calls and other interaction work. So you should not test the component's function. That is done in system testing. So the integration strategy depends largely on the development strategy, but it also depends on work you have done so far. Like for example, you can integrate only available component. That is why the implementation plan is really important. So to make sure that you implement the system part in an order that makes sense for integration, these were also principal objective of the development strategy. With the parts that are available, you have various choice on how to proceed. So the most obvious approach is to put all the parts together and see whether they're working. They're working together. So this is so called a Big Bang strategy. We call this a Big Bang strategy. This Big Bang strategy is an attractive alternative because it requires the least amount of test development. It is, although it is rarely successful, however, particularly with a poor quality system, in one large system, for example, integration testing found 30,000 defects, although this was for a system of several million line of code. So this is based on experience. So it's not unusual to find 10 or more defect per kilo line of code during integration testing. So this is actually why development quality is important. Important to fix each defect found in integration test. So to fix each defect found, integration test can take an average of 5 or 10 or perhaps more hours. Generally, the bigger and more complex the system, the longer it will take to diagnose and fix each defect, unless you have a very high quality parts. the Big Bang theory is not a good idea. Okay, so we have the advantage of the Big Bang theory, Big Bang strategy, that everything is finished before integration testing start. Okay, disadvantage, in general, it is time consuming and difficult to trace the cause of failures, okay, because of the late integration. Okay, there are pros and cons, okay, and that. Okay, let us see the next build and integration strategy. Okay, the second one, okay, the one at a time strategy. Okay, this is second strategy is to add the available parts one at a time. So because you have a simpler system with a fewer problem, so this strategy is generally more effective. Okay, why it's effective? First, you get two parts working together, and then you add a third and get it to run. Then you can add a fourth part, fifth part, and so on. With each addition, you look for problem with the newly added parts. This will usually let you to fairly quickly to the problem causes. So this strategy has disadvantage too, unfortunately, okay, which is it's requiring more test development work. Then we go third, build and integration strategy. Okay, we have here the cluster strategy. So this is the strategy. It's to add parts in cluster. Okay, you can't, however, simply take whatever parts, okay, happen to be implemented. Okay, instead, you examine the available parts and pick those of particular type. Okay, that is, you try to identify a class of related component. Okay, try to find, okay, to identify a class of related components and try to integrate them. Okay, like an example might be, okay, all those parts concerned with file handling, the printing, or some other system area. So this approach could be helpful. Okay, for example, if a certain function were needed to test the rest of the system, this strategy could also reduce the need of special test driver and as well as the facilities. Then we have the fourth strategy, okay, is to build a flat system. Okay, to build a flat system, okay, here the idea is to integrate all the highest level parts, okay, first, and then delve down into a successive system layer in parallel. Okay, again, you can test all the new parts at once or add one component at a time. So the advantage of this strategy is that you can detect system-wide issues early. It also provides a great flexibility by quickly building a total skeleton of the system. So the principal problem with this flat system strategy is that it usually requires a large number of steps, or we call it a special scaffolding, okay, to provide a dummy return for all the functions that are not yet available. Okay, so unfortunately, no integration strategy will be best for all systems. Okay, the best approach is to consider all the options and pick the one that seems best for your particular project. Unless you have a poor quality system, okay, almost any logical integration strategy will work. So don't spend a lot of time, okay, agonizing over the one best choice. In general, however, try to add new code in a reasonable small increment. In system testing, okay, you seek, okay, to find the answer for these four questions. Okay, the first one, okay, does the system properly perform the function that it is supposed to perform? Okay, the second question, does the system meet its quality goal? Okay, will the system operate properly under normal conditions? Okay, and last question, will the system operate properly under adverse condition. So in answering this question, check a number of key areas. For example, okay, can the system be installed? Okay, does it start up properly? Okay, will it perform all the function given in the requirements? Okay, will it recover like from hardware or power failures? Okay, is it performance adequate? Okay, for performance, evaluate the response time, throughput, the capacity. Okay, and you also need to know whether the system is usable, whether user find it convenient, or will they have trouble running, okay, the task and answering normal operation questions. Okay, the system testing has many objectives, okay, because you will rarely have enough time to perform all of the tests you can visualize. You need a test plan to cover those tests that are most important for your project. So the first step is to identify the principle, the main principle objective of the system, and then devise a strategy to ensure that all these objectives are met. Okay? In producing a precise design, okay, this is really important, okay, critically important in team project, because okay, it's the superficial design frequently have a basic logical problem that no individual engineer can see. These problems are generally hard to diagnose during tests, and sometimes they cannot be fixed without reworking major portions of the implementations. Okay, task planning. Task planning is done in several places in TSP process. Just as with the personal software process, PSP, start by producing a conceptual test design. eh? Estimating the sizes of the test material, and to be developed, and how long the test development and testing work will take. You need to test plan for the build, integration testing, and system testing activities. Although the build and integration plan should be simple, it is still important to plan the testing before you do it. So when completed, the testing plan describe what tests you plan to run, the order to run them, and the test material needed for each of the tests. So with a complete plan, you should be able to show how each requirement is tested. How each requirement is tested, and how the test script or scenarios cover the requirement areas. You should always know which requirement areas are thoroughly tested and which one have sparse coverage. So in addition, you should name each anticipated test, define the result it should produce, and predict how long it will probably run. Also, don't forget to estimate the defect to be found in each test phase. So the total defect repair time, and the total test time. Then next, which is you have to estimate the sizes of the test material required. In addition to line of code size estimate, you will probably need to test the scripts of interactive tests as well as test data. For some system, test data preparation can be a larger job than test case development. So at the end of testing plan, of test planning, you should have first a list of all the tests to be performed. Second, you should have the supporting materials required for each of the tests. Third, the result. You should have the result that the tests are to be produced. And lastly, you should have produced the estimate of the defect-free runtime. So defect to be found and total time for each of the tests. You will also need a listing of all of the test support material, okay, required, okay, and which tests have been support, okay, and the objective of every test as well, okay, you need that, okay, and how large these material are expected to take, okay, how long the development, okay, is likely to take, and who will develop each test support item, and lastly when, okay, these development tasks, okay, are to be completed, okay, the how, the who, the when, okay, and the what, okay, and finally develop the test material. If you plan substantial test plan, you may also want self-checking test cases, okay. They are automatically check actual test result against those planned and provide an output indicating whether the result was correct. Okay, with such test cases, you can run a large batch of a test, okay, and check only, okay, at the end to see which test found defects. In general, if you lack of tasks of a complete set of test tools, it is not practical to develop a self-checking test. Okay, tracking and measuring, okay, the testing. Okay. So if you anticipate running many tests, you will want data on test effectiveness. Okay, that is how many defects each test uncovers as a function of its running time. Then you can use this defect, okay, over our data as a figure, okay, of merit in selecting tests to include in a regression test bucket. Okay. So in a rule of thumb is to include in the regression bucket, okay, all the tests that have previously found defect as well as all the tests that verify previously tested system areas that were modified in the most recent development cycle. Okay, so because you will be running a full set of tests for every TSP development cycle, some test measurement will be helpful. So in addition to the data you record in log D, okay, and log T time, okay, log defect and log time, you need to answer, okay, the following questions. Okay, first, okay, how long did it take to run this test? Okay, how many defects did it find? Okay, what else? Does the required manual intervention, or can it be batch, okay, with other tests? Okay, is it self-checking? Okay, to answer all of these questions, you should record data on test runtime, okay, the number of defects found and the test condition. Okay, so this is a convenient way to keep this data, okay, as a test log. Okay, so here we have a test log. Okay, so these are the type of information, okay, record in the test log. Okay, test log should have the data, the date, okay, the test was run, the name of the person running the test run, okay, name and or number, okay, the product and configuration being tested, okay, the time each test was started, okay, the time each test was completed, okay, and lastly the test result. Okay. So in additions, okay, you may want to include a few of this listing below, okay, which is the system configuration being tested, okay, any special tools or facilities used, okay, whether operator intervention was required and how much. Okay, so the simplest way to record the basic information is in a canonical log that is much like the time recording log. Okay, this example, okay, given to you in the next slide. Okay, it will include all the added information in the rest report that you file in the project notebook along with a copy of the test log. So this is sample of a test log. Okay. So we have the name, okay, the member's name, okay, the team, part level, date, instructor, cycle. Okay, so each of the column here, you have the date, the test phase, product, start, stop, problem, and comments. Okay, so this is an example of a test log, or in short, log test form. Okay, documentation. Okay, our next topic is documentation. Okay, as is the case with many other parts of the software process, okay, documentation is a large subject. It's worth, okay, for an entire course of its own. Okay, for this topic, let's cover a few key points about software documentation and provide references to a few texts, okay, on the subject. Okay, you have had a course on technical writing. Now is a good time for you to practice what you have learned. If you have not had such a course, now is a good time to start thinking about this important topic in documentation. So in TSP test phase, okay, part of the team draft a review, okay, and review the user documentation, where the rest of the team conduct the test. Okay, although commercial system generally need a broad range of document to cover installation, okay, maintenance, training, okay, and marketing needs. Okay, with this uh, TSP will address only the basic user documentation. Okay, and the importance of this documentation. Okay, documentation is a very important and essential part of every software product. In many ways, the documentation is more important than the project code in one company, for example. So the engineer followed the common practice of differing documentation work until after they finished testing. They often even deferred working on some documents until after the product had been shipped to the customer. The customer became so upset by this that they finally refused to pay for the program. They told the company that they did not want the program shipped, okay, at all until they came with all the required documentation. As far as they were concerned, okay, a program without the documentation was useless. So this is really important to have documentation, when you deal with your customer, client, and stakeholder. Okay, the best time to document a function is right after you have designed it. Okay, that's the very best time. Okay, so if you have produced the document before completing the design, you will produce you will probably have to make a lot of changes. Okay, on the other hand, if you defer the documentation work too long, this will take longer than if you did it when the design was fresh in your mind. So in TSP, okay, it's include the document development work in the test phase. So with the larger system, this work should generally start much earlier, okay, and continue all the way through testing. Okay, in fact, it is a good idea to test the user document as a part of the testing. So documentation design. Yes, next topic, writing a useful and helpful user manual, okay, is quite challenging problem for software engineers. Okay, after you have designed and built product, it is natural, okay, to want to describe what you have built. Okay, unfortunately, okay, this natural desire, okay, where you want to describe the wonderful creation, okay, of your product, of your system, of your application, really leads to terrible document. And the reason is that you are writing about what you did and not what the reader wants. Okay? A useful guideline for determining the quality of manual is to look at the table of content, which is the TOC. So if the manual is organized around the product's design, it is probably a poor document. A well-designed manual should be organized around the reader's needs and not the product structure. Usually, generally, the first section should address what the user needs to know first. Okay, how to get started. Next, okay, you might explain what the user can do with the product. And finally, make it easy for the people to find what they want to know. Okay, and let's see the suggestion for user manual. Okay, so it's easy for the user. Okay, here's some suggestion. Okay, first use a glossary to define any terms that aren't in the standard dictionary. Then include a section on error messages, troubleshooting procedures, okay, and recovery procedures. Third, have an index key topic, and lastly, provide a detailed table of content. Okay, in document review. Okay, after drafting and rewriting the user documentation, have one or more of your peer reviews. So if this is a product for customer or user, run user tests to ensure that the writing is clear. Okay, the writing is clear. Okay, it's accurate, it's complete and understandable. Remember, that's the four things that you need to bear in mind. Okay, clear, accurate, complete and understandable. So some items to check in this review are the following. Here are the document organization. Okay, for document organization, is the document organized around what the user will be doing or around the product content. So user documents should address the user needs and not the product structure or the content. Okay, then second, document terminology. Okay, so does the document presume a knowledge that the user might not have? Okay, software experts often use a special terminology even when writing for people who will not understand it. So many words that are not in the dictionary should be defined. Okay, third, document content. Okay, does the document cover all the required material? Okay, fourth is accuracy. Okay, have accuracy. Okay, do the method and procedure actually work as described? Readability, is the document easy to read? Okay, read it out loud, see whether you feel comfortable saying what is written. Okay, and lastly is understandable. Okay, understandability. Okay, can lay people understand what is written? So this question is generally the most difficult one to answer. The best test is to recruit someone who has not previously been exposed to the system and ask him or her to follow the manual in using the system. Then you observe your subject's reactions. So record any problems and rework the documents to address this problem. Okay, following are some of the items to produce during the test development. The first thing is a build completeness test. So the first step in integration testing checks that the system has been built and that all the planned components are included. Think of this test as a roll call check that verifies that each component is present. Make this as simple as a test package as you can. For a small system, it should even be a manual procedure. Okay, like second one, for the test development. Second is the integration procedure for testing all interfaces under normal and error condition. So this test verify that build has produced a system that is ready for the system test. From the build completeness test, you know that all the components are present. Now you make sure that the build system can be started and run. that all components can call the other components, and that all system interfaces are properly matched and function. So this is not a comprehensive test. Okay, it demonstrates only that the interfaces match and function properly. Okay, and the integration test material is the third, yeah, uh, third item to produce during the test development. Okay, the integration test material. Even though each of the tests is simple, okay, so interface testing requires preparation. Okay, you need to prepare early before you build up the interface testing. So because you may have to test many interfaces and a wide variety of condition and parameters value, you may want to you may want a simple automated procedure to walk through the test and indicate that they have been successful completed. Okay, for a small system, however, manual driven interface tests are usually adequate. Okay, then okay, fourth one, the system test material. Okay, so this material should test all of the system function under normal and stress condition. They should also check how the system will be used, okay, which is during the installation, okay, conversion, okay, during the operation, or even the recovery. System testing should also consider, okay, usability, the performance, the data anomalies, and mathematical correctness and precision. Okay, because this product is being built in several cycles. Okay, you should conduct the usability and performance test with the first cycle if possible. Okay, fixing performance and usability problem is hard after a product has been initially built. So if major changes are required, they must get top priority in the next development cycle. Okay, a, a clear statement of expected result from every test, okay, will be produced, okay, as the last uh, still last we say item to be produced during the test development. Okay, so a clear statement of expected result from every test when possible. Make the system test material self-checking. Okay, so a self-checking test case is one that lists the actual result, whether or not they are correct. When you run a batch of tests, okay, this capability allow you to quick to check whether there were problem. Okay, making this test self-checking may take extra work. Okay, but this is often a good investment. Okay, which particularly for tests you expect to use. Okay, the regression testings. Okay, subsequent to system building. Okay. So this is example of TSP test scripts. It's much smaller, I can see here, but you can refer to uh, the sample that given to you in ELIP, a full A4 size for each of the cycle. Okay, on your left is actually the TSP cycle 1, okay, integration and system test. Okay, we call it script test 1. Okay, the purpose of this script test 1 is to guide a team through integrating and testing the product component into a working cycle 1 system. Okay, the entry criteria, okay, the team has developed a strategy and plan, okay, have completed and inspected SRS and SDS, okay, specification, both of the documentation, SRS and SDS, okay, and have implemented, inspected, and unit tested the component under configuration control as well. Okay, and the student have you have covered, okay, chapter 9, okay, which is the integration and system testing topic. Okay, in general, when defects are found in build, integration, or system test, the quality process manager determines, okay, whether the testing should continue. Okay, every defect found, okay, you should record it in the log D and reviewed by the entire team as well. Okay, some few activities, okay, in this script test. Okay, one, okay, the activities are test process overview, then you have the test development, you have the build, okay, integration, okay, and system testing, and lastly is the uh, documentation. Okay, for the exit criteria, okay, it should be integrate and tested the cycle 1 product. Okay, you have complete the log D, okay, log defect and log test form for all the tests, and completed and reviewed user documentation. Okay, and lastly, okay, time, size, defect, data entered in TSP support system. Okay, and then continues with the similar. I can say that they are almost these tests when a test and script are almost identical, except that in test N, okay, you will have data from the previous test cycles. Okay, you also do regression testing with test and script. Okay, something that is unnecessary for test 1. Okay, for your project, you will just focus on just test cycle 1 only. Okay. Okay, and in the rest of the slides, we will show you templates, okay, of test case and RTM. Okay, requirement traceability metric. Okay, for for this one here is a test case template and example. Okay, so this is how you're going to use the test case template. Okay, the log test TSP was been discussed earlier in our previous slide, and for this is test case template, and you have the test case number, system, designed by, executed by, short descriptions of the test case name, subsystem, design date, execution date. And remember, each of these test case actually taken or extracted from your use case specification, okay, which is the scenarios. Okay, you have basic scenarios and alternative scenario and exception scenario. Yeah, so for example, in your basic scenario, you might have a few user stories. So one of the user stories is can be added in this test case template. Yeah? So these are the information of the test cases, okay, with the preconditions given, okay, and the walkthrough of all the steps. Okay, you have the steps, number, action, expected system response, pass, fail, and comments. And last one, a section will be the post condition. Like, let us see the sample of a test. Okay, so this is a simple test, okay, simple example. Okay, the test here for the the teller machine, okay, designed by ABC. Yeah, short description: test the ATM change pin service. Yeah, test case name, change pin, subsystem is pin, yeah, and the date. Yeah. For the precondition, the user has a valid ATM card. The user has accessed the ATM by placing his ATM card in the machine. Yeah, the current pin is 1234. Okay, the system display the main menu. Yeah, then you have the steps here. Yeah, on the cases. Okay, so the first one, click the change button. Yeah, what the system respond expect was the system display message asking the user to enter the new pin, and then you enter a new pin 555. Yeah, the system display a message asking the user to confirm, okay, or re-enter the new pin. Okay, you re-enter the new pin 555. The system display a message with successful operation. So the system asks the user if it wants to perform other operation. Okay, lastly, click yes button. Okay, the system display the main menu. Okay, so the pros condition, okay, the new pin wherever is saved in the database. So this is a sample of a simple test. Okay, I would say it's a basic scenario. Okay, simple scenario. Then given here is the much more complex example. Okay, see much clearer here. Okay, uh, have the test the ATM change pin service. Okay, same as before. Okay, but there's a few changes or additional to it. Okay, you have a precondition. Okay, the user valid ATM card. The user has access ATM by placing his ATM card in the machine. Okay, the current pin is 1234. Okay, the system display the main menu. So at the first five steps here, okay, is similar like the one that we have earlier, the simple one. Okay, so for the six, okay, you repeat, okay, 123, okay, using another pin, say 666, and you click no button. So the system uh, is exited and display a greeting message asking the user to place in with ATM card in the machine. Okay, you have the third condition, you have one, and the second condition, okay, which is you repeat, okay, the step 1 2, okay, above using another different pin, which is 777. System display message unsuccessfully operation and asking the user to confirm a correct pin. So you say from the simple example previously in this previous slide is like a basic flow, a happy scenario, but for this complex task here is given is an would say exception flow and as well as alternative to a exception flow. Okay, where you re-enter, like you enter a wrong confirmation, okay, the error unsuccessful error will display. Okay, when you enter 777, okay, the system display message of successful operation. The system asks the user if she wants to perform the other operation. Okay, lastly, no, the system exited and displayed the greeting message. So these are the post condition. Okay, the new pin is saved in database. Okay, and the new pin is saved in database, and last one, new pin 777 is uh, will be saved. Okay, you have test the happy path, happy scenario, then also the failure or exception. Okay, in step 9. Okay, you have pass. Okay, can you check, and as well as any comments if applicable. Okay. Then for RTM, okay, requirement traceability metric, this is really important when you have you want to compile or summarize, okay, the overall picture of your system. Okay, so this we're gonna talk about what is RTM, okay, requirement traceability metric. So it displays all of the functional requirement from SRS, okay, software requirement specification, the design component that address each of the requirement. Okay, then the source file. It also display the source file and procedure within them that implement the requirement. Okay, and lastly, okay, we display the test cases that verify, okay, the proper implementation of the requirement. And how we're going to build the RTM, start the RTM as soon as, okay, you have started writing the SRS, okay, as your baseline. Okay, populate it as the development progresses, okay, rather than waiting until the end of the project to fill, okay, in all of the boxes. Okay, by entering information into the matrix as it becomes available, the matrix becomes a working tool. Okay, it's like a guideline, a benchmark that helps to prevent a problem with a final product, not just a time wasting overhead activity. Okay, so this is example of requirement traceability metric. Okay, you have the top here, top corner here, requirement traceability metrics. Okay, system, you have system, client, system start date, system schedule, the delivery date. Then you have the arrow here, okay, from left to right, filling sequence. Okay, you have the software development phase. Okay, so from this left corner here, the filling sequence, requirement, design, column, okay, implementation, and testing. So here you can fill up, okay, out requirement number, requirement names. Remember, based on your use case spec as well, okay, all the requirements that you have specified in your use case spec. Okay, you have like requirement name, okay, priority, analysis, use case, story. Okay, you have the design. Okay, where in the design you can add or include the what are the architecture, software, okay, subsystem, as well as the module. Then you just label the where you put the diagram class, sequence diagram class. Okay, and for implementation, okay, you just label, okay, your source file, okay, class name, okay, function and procedure, okay, the programmer who handle the task. Okay, then you have the testing, you have the unit number. Okay, add in the unit of system test number, test cases number, pass or fail. Okay, and the tester who tested the uh, document, okay, of test cases and test comments. So let us see the sample have been filled with some information. Okay. Okay, let's see. Okay, we have a software development phase. Okay, check. Okay, for the first column of requirement, oh, sorry, find the pointer. Okay, so here the requirement, you have requirement 1.1, 1.2, 2, and 2 and 4. Yeah, the first requirement, balance inquiry, cash withdrawal, cash deposit, and bill payment. Yeah. Then these are priority, low, high, medium, and low. Okay, then these are the initial of the analysts who involved in this task. Okay, so this information requirement column. Okay, for design. Okay, what are the architecture of software, subsystem, or modules involved? Okay, you have balance for balance inspection, inquiry. Okay, for cash withdrawal is cash. Okay, cash deposit is cash. Okay, it's like an object here. And diagram classes, if any, you can just add in figure, which figure or which diagram or which page. Okay, then you have for implementation, okay, what are the source files involved, okay, for each of the requirements. You have balance, okay, you have the cache, okay, to cache, okay, and yep, then you have classes, method, function, and procedures, okay, involve programmer, initials. Okay, you have the unit testing, okay, just name, okay, label, okay, test case number, okay, and pass or fail. So these are the corner where you do the checklist, okay, and who's the tester, and provide, okay, the testing. Okay. Okay, in summary, the purpose of testing is to assess the product. So this chapter actually cover both testing and documentation. So the purpose of testing is to assess the product, not to fix it. So with this TSP, however, okay, you have the data to judge, okay, which part of the system are most likely to be defect prone. Typically, those modules with the most defect in the test are likely to have the most defect remaining after test. So these modules should then be pulled from the test, okay, fixed by the developer. So try to fix them in test, is time consuming, okay, and rarely is affected. So in building in the build and integration step, you assemble the parts of the system, make sure that all the necessary parts are included, and ensure that all of their interfaces function properly. Okay, so in test planning, describe the tests you plan to run and in what order. Describe the test material that are needed to run each test. Then name each planned test and specify how long you expect it to run. Okay, the anticipated test result and the sizes of test material to be developed. Okay, and additions to a special test code you may need to for the interactive test script and test data. Okay, and in the testing phase, okay, of each development cycle, some member of the team draft a review, okay, the user development, okay, while other member do the testing. Okay, yeah, let's see, a well-designed manual is organized around the user's need and not the product structure and function. So the first documentation step is to produce a complete outline and then to review it with the test group to make sure that both groups are covering the same topic in the same way. So in writing, use short sentences. Okay, use short sentences, use simple word and phrases, and lot of lists and bulleted item. Okay, after you have written and personally reviewed the manual, have other to review it. Okay, for a product that will be delivered to an user, also test the product, the test documentation with a typical user and during the system testing. Okay, and that is all for today. Okay, on the lecture 9. Okay, SE Lab TMP 3413. Okay, topic integration and system testing. If you have any questions, you can just email me or down in our forum section. Okay, that's all for today, and see you, okay, in our next topic.